Hello there, this is Mr. Benchy again. In this tutorial, we continue to go through problems on the topic of thinking scientifically about psychology, thinking scientifically about the study of behavior. Question, which of the following is a statistical measure of both the direction and the strength of a relationship between two variables? Now, just going to quickly go through the inferior answers very quickly. A theory, well, a theory is a theory. It can be relevant to a certain correlation, but this is not specifically a correlation category. Factor analysis. You might have come across factor analysis as introduced to you the way that statisticians have come to a certain conclusion. For example, factor analysis was the primary statistical instrument used in determining how we formulate our understanding of traits, personality traits. The context of having used them, the concept of having used such results were the formation of personality inventories or personality questionnaires. Questionnaires allowing us to evaluate, to document, to describe people's personality. In short, personality tests. Okay? Personality tests. Now, factor analysis is not exactly a topic of interest. Well, it's a topic of interest, but it's not exactly a topic that you are expected to become familiar with at the freshman level of psychology. It is a statistical technique. Okay, so theory, not the best answer. Factor analysis, it's not even exactly relevant per se. Now, an operational definition, if you recall from your reviews, operational definition refers to the act of operationally defining what to measure. Okay, it is a process of figuring out per se. The process of figuring out what to measure and how to measure. So it's the what and the how. Now, both of these are important considerations when conducting research. And if the research relates to looking at the strength of a relationship between two variables, it might be relevant to the question being asked. However, operational definition is not a statistical measure. It is more a part of the scientific method. It is more a part of the research process. Okay? So, well, unfortunately, not exactly an applicable answer. Now, take a look at option E, the descriptive method. The descriptive method, not the best answer. And here's why. Here is why. According to the level of constraints, we know that there are three kinds of research that differ along the lines of constraints: descriptive, correlational, as well as experimental. The primary concern when it comes to descriptive level of research is to observe. We're making observations, we're making note of what we see. We're documenting our observations in order to generate information. And the information is helpful in determining how to take the research question further. whether we now design a correlational setup to study the topic or not. That's the concern. We're not concerned about the existence of a relationship. We're not concerned about the why. We're not concerned about explaining what we see. Correlational, however, is the process to explore whether or not a relationship exists. A relationship, or simply put, a connection. It is the exploration of whether a relationship or a connection exists between two variables, connecting the two. If two variables, they change in the same direction, we refer to it as a positive correlation. If the two variables change in opposite directions, we refer to such a correlation as a negative one. Now, experimental, very quickly, refers to the experimental setup explores causation or causality. You can use that word too. It is a question of whether one variable causes another variable to change. If one variable influences another variable to the extent of itself changing, we manipulate one variable and we measure the other variable to look at the potential of a cause and effect relationship. The strength of a relationship between two variables. Back to the question now. When looking at two variables, the setup will either be correlational or experimental, as you see. And the strength would have been explored before going into the kind of setup allowing us to look at causation. That is to say, correlation. Correlation is the stage, is the setup before entering the experimental stage. Correlation. Now, to understand the strength of a relationship between two variables, the best way to do so is to imagine a certain number line. If you're taking notes, I strongly encourage you to draw this line. Correlation coefficient is a number. It is a number. It is a number that statisticians, and since behavioral scientists, psychologists, we've adopted the use of statistics in describing and measuring or analyzing results and outcomes captured using numbers. We use the letter R. For example, if R is presented as being equal to 0.31, all right? So this is a correlation coefficient. This is a correlation coefficient that describes, number one, a positive correlation, and number two, it gives the relative strength of the correlation, the relative strength of how closely correlated two variables are. Back to the number line, we will label this end 1.00 and the other end 1.0, positive 1.00. Any negative number that exists between negative 1.00 and 0, they describe a negative correlation. And naturally, any number that exists between 0 and positive 1.00, they describe a positive correlation. There you go. Do you see? So the sign of the number tells you already whether it's a positive correlation. A positive correlation is when A increases, and we also observe increases in B. That's one situation of a positive correlation, as well as if when A decreases, B also decreases. That is to say, when two variables vary in the same direction, when they change in the same direction. Negative correlation, when the variables change in opposite direction. When one increases, the other decreases. That's a negative correlation. The second piece of information that a correlation coefficient gives us is the relative strength of the correlation. The closer a positive number is to positive 1, the stronger the positive correlation. The closer a positive number is to 0, the weaker the positive correlation. And on the other side, for negative correlations, sort of the exact opposite. The closer a negative number is to negative 1.00, the stronger the negative correlation. And the closer a negative number is to 0, the weaker it is. So you can see in both cases of positive and negative correlation, the closer the numbers are towards 0, the weaker the relationship is. And here is why. When R is denoted by the number 0.00, there is essentially no relationship that we observe between the two variables. There is no relationship. There is no correlation. The correlation is so weak that we deem the situation as having no relationship. The two are not connected at all. I hope this tutorial helps. Nothing is in the way for you to rewatch the video and gain further clarity and mastery of the subject matter. More of such will be made available in the foreseeable future. Hit the like and subscribe buttons to stay up to date of quality tutorials that can help you succeed in your studies. You've been watching Mr. Benji at Mr. Benji Now on YT. I'm a college instructor in Vancouver, BC, Canada. Until next time.